And the next couple of things we go through are the standard solutions. A standard solution is a solution where you absolutely, for three significant figures, know the concentration. And the way that we can know that is that we know the mass of the salt that we're using to make it. We're going to use distilled water, which has had all the other ions taken out of it. So distillation is first of all evaporating it, then recondensing it, so it leaves all the other impurities behind. And the other thing that we're going to know is that this salt is not going to react with air, so it's absolutely pure. So what we've got here is what we call anhydrous sodium carbonate. So it looks different to the sodium carbonate that you use for washing your clothes, because that looks a bit like an opaque crystal, relatively large. This is a very fine powder, so it's a little bit different in its appearance. The other thing that we are going to do is we're going to make it in a thing called a volumetric flask. Now these are completely different to a conical flask, for example, because they are precisely a value if you fill them up exactly to the line that we've got here. And they have a temperature written on them, so if you're outside that temperature range, they're imprecise. And if you go too far over the line, you have to start again. Alright? Because that line is exactly, in this case, 250 mils, plus or minus, it says, 0.3 mils, which is pretty darn precise. So it's precise to three significant figures. It's exactly 250 mils. So we're going to get to the practical side of it in a moment. The reason we're going to make this sodium carbonate solution, standard sodium carbonate solution, is for some experiments coming later, some titrations. We're going to need to know its exact concentration, but we're looking for 0.05 moles per litre. So how do I know how much solid to put into this 250 mils? Well, that's what we're going to look at now. If we're looking for it to be this concentration, and I know the volume is going to be 250 mils, then I can use this triangle to work out how many moles I actually need. But we can see it. So C equals N over V. Well, I want to know how much to use, the amount. I want to know this. My desired concentration is 0.05. Okay, I don't worry about 3 at the moment. That'll come later. And my volume is 250 mils. But actually in here, and the reason I use a capital V for volume is to remind me that it's capital L for litres. 250 may be my mils that I need, but I've got to put that over 1,000 to get it into litres. So I do this calculation here. So 0.05 times 0.25, that becomes the 0.0125 moles. That's the amount I need. Now I'm working with a mass. I want to know how much to weigh out of this. So what I'm going to need here is the other triangle. Where I've got N, little n, and big M. And in this case, I want to know the mass to weigh out. So I go mass equals little n, which I take from there, and my molar mass is actually written on the container, so it's quite convenient. And it says it's 105.99. So I do that. And it comes to 1.32 grams. Now, that's quite hard to get, exactly 1.32 on my scales. I might end up weighing a little bit too much and get 1.33, and then I take a few crystals out and now it's 1.30, and add a couple more and it goes to 1.34. And I just can't get exactly 1.32. It might be too hard to get. That's okay, because actually we're going to do the calculations in reverse to find out what the concentration of our solution is when we make it. So we'll get to that one later on. So we've just had a look at what mass we need. We want 1.32 grams of our sodium carbonate to go into our 250ml volumetric flask to make our standard solution for our experiments starting later this week. We've got to look at how we make it. And to weigh it out, most books will say to do this on a glass dish. I don't like that because I like to dissolve a bit of the powder first. So what I'm going to do is I'm going to put a small beaker onto my scales, and I'm going to zero my scales with that beaker on it. Then I'm going to add my 1.32 grams roughly. Now I may not get 1.32, may go a bit over, but I'm not too worried, to be honest. Yeah, 1.36. It's close enough, honestly. I'm not going to spend heaps of time trying to get it precise. As long as I don't go to 1.4 and don't stop at 1.25, then I've got enough in there for the experiment. Okay, just believe me on that one. Then what I'm going to do is take this off the scales. So the scales are going to one side. Having recorded that 1.36 grams in my book. Okay, so I need that, the mass that I did actually record, gather. Then, you can see I just got rid of my stirring rod, which is poor planning. Then what I'm going to do is I'm going to put some distilled water in there. And you'll see it goes quite cloudy and quite clumpy, because a lot of the crystals are actually becoming hydrated, and some of them are dissolving. So what I'm doing here is just basically trying to dissolve the crystal as best I can. Okay, and before we started I had rinsed this out as well to the beaker. Now I don't actually want the solid bits to go into here. I only want them to go in once they're dissolved. The reason I do this is that to try to mix it once it's in here, you'll still end up with solid C on the bottom. It just doesn't happen fast enough. So I'm trying to get this done as well as I can. And then I'm going to decant, which means pouring carefully off the top, decant the solution off the top into here. And actually better practice would be if someone could get me a funnel, please. Which I'll just quickly rinse with water as well. Is it still showing on the screen or?
Not quite.
Not quite. What about now?
Yeah.
Cool. So I'm decanting the solution off, and it'll leave some solid behind, and that's absolutely fine. Right, first bit of solid started going through, so I'm going to stop there. And again, I'm just going to add more distilled water. Use my stirring rod again to try to dissolve that as best I can. I'm nearly there, which is great. So actually now I can pour quite confidently. And then do one more rinse in here so that I've left nothing behind. So you see that I'm going down the walls completely. And then pour that in there. And lucky last, I'm going to do a little rinse there just to make sure there's nothing left in the funnel. Alright. There's a little bit of surface tension holding some water there, so then my next job is to fill it up to exactly this line. So really what I do is I just pour it until we get to about here. And then I'm going to go very, very slowly, or I may even go so slowly that I use a dropper. Now, if you get to here and you still notice some bits are undissolved, stop. See, there's still enough room for me to actually mix it. So it's worth doing if you notice any crystals have got through without dissolving. Alright, give it a few inversions to dissolve it. And then keep going. and it's time consuming, as you can see. Okay, now's when we go slowly. And I'm going to get my head level with the line, and I'm going to very slowly pour the liquid in, and I'm going to anticipate that it's about to hit the line. So there's that last drop that came out. So I anticipate. If you're worried about that, get a dropper and just use a dropper for the last little bit. If it goes over the line by more than about 1 millimetre, you've gone too far. And remember that liquids have got a meniscus. It's the bottom of the meniscus, not the top. So it's the bottom of the curve bit that we're aiming for on that line. Okay, my last thing to do is just to invert it a couple of times. Again, just to ensure that it's what we call homogeneous, so the same concentration throughout. And then I would put my name on it with a marker so that I know that that's my solution. Right, so now we've made our solution, and we were meant to use 1.32 grams, but we didn't. That doesn't mean that our solution's ruined. It means that we have to work out exactly what its concentration is, so it is able to be used as a standard solution. So I recorded that we had a mass of sodium carbonate of 1.36 grams. This is a 250 milliliter flask, which is 0.25 litres. Okay. So what I want to know is what's its concentration in moles per litre. Grams per litre would be very easy, but it's not what we're after. We also know, because it's set up on the container, that the molar mass sodium carbonate and hydrosodium carbonate is 105.99 grams per mole. So before we started with using the NCV triangle, then we used the NNM triangle. This time we're going in reverse. So we're going to use the NNM triangle to find out our amount of sodium carbonate in there. So we go N equals little n over big M. So 1.36 over 105.99 is 0.01283. It just carries on. I'm only going to write down 3 significant figures because that's all I've got from the maths. But actually I'm going to keep that exact number in my calculator. Alright, I'm not going to clear my calculator. I'm going to leave that as it is. So 0.0128 moles, which is a little bit different to what we had in our original one where we were after 0.0125 moles. So you can see there's a difference there already. And that third significant figure is important. Now I know that, I can substitute that into my NCV triangle. I now know this and I now know this, so I can find concentration. So I'm going to go concentration sodium carbonate equals N over V 0.0128 over 0.2500. And again, 3 significant figures in this one, so that'll be my limit. So there's no point putting that 0 there because it's not going to matter. And I get 0.05, which is what we wanted, 13 moles per litre. So it's a little bit more concentrated than what we were after. But it's pretty close. We wanted 0.0500. That was ideal. We didn't quite get it, but that's okay. Now I know this value, I will write that number on here as well. So I'm going to put 0.0513, and an abbreviation you often see for moles per litre is just a capital M, so the same as that one there. So I'll put that, 0.0513 in the big M, and Na2CO3 on it as well, so we know what the substance is. Alright, that standard solution is now available to be used for titration, which is what we're going to be doing later in the week. Right. So your task now is to put all of this together. We've done the first step, So that's okay. On our other board, that was predicting the mass we need, which is 1.32 grams. Then you've got to make a standard solution, which the second video, the second bit showed. Then once you know exactly how much you did use, which probably won't be 1.32, calculate to 3 significant figures, so 1, 2, 3, what is the actual concentration of your solution.